Hello and welcome to Chapter 3 review. Here we can kind of fill in all the math notes from the chapter and get it all in square. So this first game, we're choosing first a square and then we're choosing a circle. So we don't have branches that go either a square or a circle because we choose both. So first we need branches that are going to be our square possibilities. It could be yellow or blue or red. And we put the probabilities on there that make it work. There were 6 of them in there, 3 of them were yellow, 1 was blue, and 2 were red. So here's our square possibilities. And then from there, our circles could either be yellow or red. And so we put the probabilities on there. So the last thing you do with a tree diagram is to get the final sample space, which is yellow, yellow. And that possibility, you multiply these together and get 1/6. Another option that could happen is you could have yellow and then red, and that would be 2/6. You could have blue and then yellow, and that is 1/18. You could have blue and then red, and that is 2/18. You could have red and then yellow, and that is 1/9. And you could have red and then red, and that is 2/9. Now I notice that these are the 6 events that are 6 outcomes in the sample space, but they are not equally likely. They are all different chances of those things happening. In the area model, if you draw an area model, we would have yellow, yellow here, 1/6. The same thing that I've got here. It's just another way to represent it. Red, yellow would be 1/9. Yes? Blue, yellow would be 1/18. Yellow, red would be 2/6. Red, red is 2/9. And blue, red would be 2/18. So then the question asks, what's the probability of winning the game? And to win the game, you would have to have, I believe it's a blue and then a red. So that would be here. So blue, red is 2/18. Blue, red on here is 2/18. So the probability of winning the game is 2/18. So when can you use an area model? Well, you can use it here because there were only 2. There's not 3 flips or 3 different things happening on. So that's the first important thing. Only 2 things. And the second thing is that those events are independent. Independent means the outcome of the first does not affect the probability of the second. So whatever I grab in the square bag does not affect what I grab in the circle bag. If it was different and the outcome changed, if I was doing squares and squares, then I can't use an area model because the outcome of the first would affect the probability of the second if I was not replacing, if I was not putting them back. When can you just list the sample space? You can list the sample space when they are all equally likely. So when there's the same chance of everything happening, that's when you can just list them. Would that work here? No, because these are all not equally likely. The least likely thing is to get blue, yellow. The most likely thing to happen is probably to get yellow, red. But because they are not all the same probabilities, we can't just list them and say, otherwise we would say, hey, there's a 1 out of 6 chance of winning this game. But that's not true. It's a 2 out of 18 chance, or 1/9. I should probably have reduced this to be 1/9. That's the best answer. Okay? You can always use a tree diagram. That will always work, but sometimes it's the most annoying one. 3 different ways that you could represent the sample space. Okay, what's a union? A union, we'll start here. The key word for union is or. So if I said the union of 2 events, that's saying you need to be a member of at least one set. So if it was the union of wearing jeans and having blue eyes, you need to either be wearing jeans or have blue eyes, or wear both. But if you're in at least one of those groups, then you're in the union. The intersection, the key word is and this would mean you would need to be in both groups. So we'll say member of both groups, both sets. Complement means not in the set. So if I said, who's the complement of blue eyes, means anybody that doesn't have blue eyes. What's the addition rule? The addition rule is very important. The addition rule is what you use when you're trying to find the union. So union of A and B. And to find the union, we need the probability of all of A plus the probability of all of B, but we need to subtract the intersection, the place where they overlap. Probability of the intersection. Because we double counted it. So for the union, we could be all of A plus all of B, but we need to subtract this middle section because we have double counted it. So we use the addition rule when we're talking about a union, an OR problem. Okay, if you want two events to both happen, what math do you perform with their probabilities? Well, just like with the squares and the circles. If I want this kind of square and that kind of circle, the and is very important. That tells me to multiply. Or if I want the rat to choose this path and that path, then I multiply all those probabilities. If you want one event or the other, then I add. I want the rat to land here, or here, or here. Well, then I'll add those three probabilities together. Explain how to calculate expected value. Expected value is always your amount of winnings or money or what you're getting points times the probability that that happens. So we take plus the next amount of winnings times its probability and so on and so forth. All the winnings, all the possible things that could happen times the probabilities that they happen. So in this example here, they tell you that these are equally likely. This 90-degree angle tells us that's 90 out of 360, which is 1/4. And if these are left over, these are equal, then that's basically, well, I could change that into 2/8, that these that are 6/8 left, and I could split that into 3/8 and 3/8. So there's the probabilities of those things happening. So to find my expected value, I could lose $6, and there is a 1 out of 4 chance of that happening. Or I could win $3, and there is a 3 out of 8 chance of that happening. Or I could win $5, and there is a 3 out of 8 chance of that happening. So then I just multiply these. Negative 6/4 plus 9/8 plus 15/8. I need a common denominator. I can't add them up until I have a common denominator. So this I'll double the top and bottom. Make it 12/8. So there's 24 minus 12 is 12/8. Now I can go to the calculator, and that is $1.50. So I am expected, on average, to win $1.50 each time I play over the long term. Is it a fair game? No. It would only be a fair game if it was 0. This is weighted for me to win money. This is rigged in my favor right now. Why is the slope ratio for an angle with an 11-degree angle, why is that 1/5? Why is it if I hit the tangent button of 11 degrees, I get about 0.2? Well, because if I have this angle of 11 degrees, any place that I draw a triangle here, let's say I draw it here, the ratio of the change in y over the change in x will always be in the ratio of 1 to 5. There's going to be one triangle here that goes up 1 and goes over 5. There's going to be another one at some point that's maybe up 2 and over 10. Again, in the ratio of 1 to 5. There's going to be another one up here someplace that's going to go up 3 and over 15. Every place I draw a triangle, and even if I did them here, they would all be fractions or decimals of those things, but they would all reduce to the same ratio. The ratio of change in y over change in x, when this is at 11 degrees, is always the same. It's always 1 over 5, or roughly 0.2. That's why when I hit the tangent button on the calculator and I say tangent of 11, it'll tell me 0.2 or 0.194, because that's always going to be the case. How do you label the sides of a triangle? This is my angle of reference. The one across from it, or opposite, this 4, is going to be the opposite side. That is my change in y. The one next to it is my adjacent. That is my change in x. So tangent is the slope ratio of the change in y over the change in x, which we know is the opposite side over the adjacent side. Set up an equation using tangent. Okay, so the slope ratio of 18 degrees, which I know is tangent of 18, is equal to the opposite, which is 4, over the adjacent, which we don't know, that's going to be a. But from here, I can do on the calculator tangent of 18 degrees and figure out what is the slope ratio of 18 degrees. Change in y over change in x will always be equal to the number 0.32. And then to get a by itself, I'll drop a 1 under there, cross multiply, 32a equals 4, and then divide. And my calculator friend will tell me a is equal to 12.5, roughly. And this could be anywhere from 12 to 12.5, depending on your rounding, depending on how much you round. So that is a review of the entire chapter. Good luck in your test.